Alright, wanted to talk today about acids and bases, and it's something that we've talked about just briefly, just mentioned it in passing. We mentioned just a little bit before we left for Christmas break, but hopefully you have a little bit of a base knowledge about this stuff, maybe from 5th grade or something like that. What do you remember from the pH scale is the first thing you can see right here, what I want to ask. We had a certain number range we talked about. We had a certain what was the middle, if you go down from there, if you go up from there, from the middle, how does it work? And that's something we'll talk about more towards the end of this week and into next week before we test next Friday. We will see how substances are labeled as an acid or base, how they interact with metals, and it's stuff we're going to use every day. It's stuff that we're going to set up in a lab. We'll do some computer work also. For example, citrus fruits, really any kind of fruit is going to be considered an acid. And we'll talk about how and why. And anything that's a soap or cleaner will be known as a base. And usually when you talk about what do we eat or things like that, usually we're going to eat more of the acid things than the base things, and we'll talk about again why that is, how that works. But knowing the difference and being able to identify an acid or base without touching, tasting, smelling, things like that, in a safe way is going to be our priority for the week. All right. Moving forward here, we got some things we want to learn. Hopefully we get these down by early or end of this week, early next week. First thing is describe the 4 properties of acids. So you should have, move this, 1, 2, 3, and 4 for your properties of acids. Alright, then we're going to have 4 uses of bases, so the same thing. 1, 2, 3, and 4. Alright, then we're going to go opposite that and go bases. 4 properties of bases, 1, 2, 3, 4, and then 4 uses of bases. Alright, so that's what we're going to do over the next little bit. Obviously, you can pause this anytime you need to write something down. Alright, moving forward. This is our unit visual. This is something that we'll focus on, again, more towards the end of the week. We'll reference it a few times, but you can see the scale, and this is not a great picture of it, but the scale will go between 0 and 14. So 0 here and 14 there. Alright, 7 is neutral, it's in the middle. Okay, 7 is neither an acid nor a base. Alright, the further you move down from 7, so 7, 6, 5, 4, 3, 2, 1 to 0, the more acidic it becomes. So 0 is the most acidic substance you can have, and you can see there the only thing on there is that human stomach contents. As you see, human stomach contents can be anywhere along this line, but definitely be a 0. Alright, that's like your different, let me think about it. I think it's like sulfuric acid. We'll talk about that more later though. As you go up from 7, 8, 9, 10, 11, 12, 13, 14, it becomes more and more basic. Alright, and you have things like seawater, detergent, ammonia, bleaches up there in the base range. Those antacids, like the tablets that you chew when your stomach's upset, those things are also bases. So we'll learn about the scale, but again, just know 7 is neutral. Anytime you go down from 7, 6.9, that's an acid, on down to 0. Anytime you go up from 7, 7.1 on up, that's a base. Okay, bases, and we'll talk about the properties of them here in a little bit. Okay, this is a vocab term that we'll get when we get back. But basically, an acid is any compound that increases the number of hydronium ions when dissolved in water. So any compound that increases the number of hydronium ions when dissolved in water. Now, you might say, what's hydronium? Hydronium just is where, when you put an acid in water, it's going to break apart. Now, next week we'll talk about how many or how much break apart. That determines how strong or weak it is. But when an acid breaks apart, it breaks apart and it leaves this H. Okay? Right there. So when you find those H's, H pluses in water, that means that an acid is broken apart. That H attaches to water. So you have H plus H2O gives you H3O, which is hydronium. So you have H plus H2O, which is water, and that gives you H3O, H3O. A little plus there, and that's for hydronium. Okay, so that's how you know you have an acid, is when water gains an extra hydrogen. Okay, so H2O plus H, and you add a little plus here, right? That makes it H3O. All right, and that's hydronium. So that's an acid. Now, the 4 properties of acids go as follows. Number 1, so again, you go back here. All right, put your little 1, right, then 2 and 3 and 4. Number 1, acids have a sour flavor, and we saw that in one of our questions the other day in our TCAP practice kind of thing, our mid-year assessment. Acids have a sour flavor, so that's why lemons, right, and other fruits is because of this citric acid. So number 1, acids have a sour flavor. That's what you got to understand. That's the first property of acids. Again, you'll see this a bunch right here. Okay, so be sure we take note of this. I'll put a little X here, a little something. Taste, touch, or smell should never be used to identify an unknown chemical. Many acids are corrosive, and that's another vocab term we'll get when you get back. But corrosive means that they can destroy body tissue, clothing, and many other things. And that's a property of a lot of acids. They're all corrosive. All right, so corrosive, okay, they destroy body tissue, clothing, things like that. All right, and most acids are poisonous. Now, not all acids, and again, it depends on the degree they are. You know, how strong are they? But again, that's number 1. Okay, number 2, acids change colors in indicators. Now, that's number 2. You can pause anytime you need to. A substance, and this is what indicator means. A substance that can change color in the presence of an acid or base is an indicator. Again, it's a vocab term we'll get when we get back. All right, now you can see here, this container here at the bottom, all right, contains a substance, a liquid called bromethymol blue, and that's something that's a vocab term we'll get later. All right, bromethymol blue. Bromethymol blue stays that light blue color until you put an acid or a base in there, and then it'll change colors. All right, that's why it's an indicator. It indicates, it tells you what's been put in there. All right, so on this next page, okay, when an acid is added, the color changes from that pale blue to yellow, okay, because of the presence of an indicator. Now, sometimes instead of yellow, it may change this color. It may change theirs right here. Okay, it might change to that red color. In this case, right, if it changes, anything changes to red or to yellow, we'll call it an acid. All right, so just keep that in mind. If it changes to red or yellow, we will call it an acid. Another indicator is that we'll use is called litmus paper. Right, this right here, you see litmus paper. Okay, these paper strips change color when you add an acid to them. And we'll talk about that a little bit more. Because sometimes you'll have red paper and you'll have blue paper. Okay, the bottom line is, what color does it change to? Does it stay red? Does it change to red? Well, that's an acid. Does it stay blue? Does it change to blue? Well, that's a base. Okay, so it doesn't matter where you start; it's where you end up. Number 3 on your chart there, acids react with metals. Okay, it says acids react with some metals to produce this hydrogen gas. So when hydrochloric acid, which I'm sorry, I think that was your stomach acid, not the sulfuric. When hydrochloric acid reacts with zinc metal, hydrogen gas is formed. All right, so you have this at the bottom. It's not going to mean much to you now, but just know number 3 was acids react with metals. Okay, you can pause anytime you need to. Number 4, I'll come back to that. Okay, number 4 is acids conduct electric current. So you can pause if you need to, but acids conduct electric current. It says here, when acids are dissolved in water, okay, when you put them in water and they start breaking apart, which they do, they form ions in the solution. The ions make it possible for a solution to conduct electric current. And I'll show you a video when you get back probably of an acid being poured in water and producing electricity. You know, it turns on a light bulb or something. Okay, a car battery is an example of how an acid can be used to produce an electric current. Obviously, your battery has that sulfuric acid in it. Okay, so the sulfuric acid in the battery conducts electricity to start the engine. So it's important that you know that. So we go back and we look at the four properties. All right. So number one. Okay. Number one was acids have a sour flavor. Okay. Number two, acids change colors and indicators, and we said they change to red or yellow, so write that down too. Okay. Number three, acids react with metals. Not all do, but some do, and we'll say most do. And then number four, acids conduct electric current. They can produce electricity. Okay. So again, that's number four. Now, we're on this one, the four uses. All right, so go 1, 2, 3, and 4 here. 4 uses of acids. All right. I'll give you a few here. Write down the 4 that you feel make the most sense to you. Okay. First of all, I think sulfuric acid is important. You can say a use of that would be that it's in car batteries. Okay. It's used to make paper, paint, or detergents, if you want to say that. But sulfuric acid, to me, car batteries, you can say that. So maybe you write out number 1. Okay. Sulfuric acid. Okay. All right, and maybe car battery. Okay. Or if you want to say something about detergents, paper, paint, whatever, anything in here. Okay. You can say nitric acid if you want to do that one. Used to make fertilizers, rubber, plastics. You can say hydrochloric acid. Used to make metal from ores. You can also, I think, let me make sure. Yeah, hydrochloric acid. It says make metals from ores, things like that. Also, it talks about it's used in swimming pools to help keep free from algae, and it's found in your stomach. So again, that's an easy one to remember because it's part of your stomach acid. So maybe number 2, nitric. Number 3, hydrochloric acid. You can say citric acid, which is found in orange juice, like citrus fruits, right? That's an easy one to remember. All right. And then carbonic acid, like carbonated water, is in soft drinks. Okay. So carbonic, citric, those are easy. Citric, like citrus fruits, vitamin C. Carbonic, like carbonated beverages, soft drinks, give it a sharp taste. So again, there's 4 easy ones there, I feel like, if you just keep up with it. Okay. Moving to bases. All right. We knew acids increase the hydronium, the H+. All right. Bases are the opposites. A base is any compound that increases the number of hydroxide or OH ions. So again, hydroxide ions. Notice an acid, right, was the H+. Okay. A base was the OH. Okay. H, and O is H2O. Now, that's something we'll cover later. But when you put an acid and base together, they make that H2O. Nonetheless, a base is any compound that increases these things, hydroxide ions, O and H, when dissolved in water. So, for example, okay, this base here, when you put it in water, breaks apart. Okay, the sodium goes one way, the OH goes the other way, and you're left with these things. Okay, when you put it in water. Now, hydroxide ions give bases their properties. Some examples include soap, that you use, to clean your body. Ammonia, that you use for like window cleaner. Baking soda, bleach, detergents. All these cleaner things tend to be bases. That's some of your more common examples. Okay. Now, as far as the properties are concerned, number 1 and 2. Number 1, we'll say, is bases have a bitter flavor. Okay. They're bitter. Bases are bitter. If your mom's ever washed your mouth out with soap, you understand what bitter tastes like. Okay, some of you tasted that paper I had here one time, and if I can find enough of it, I'll let us do it again. That's a bitter flavor if you can taste it. All right, so number 1, bases are bitter. They taste bad. Number 2, it was right there beside it. Number 2, okay, is they are slippery. Okay, if you've put shampoo in your hands, it's slippery. Dishwashing soap in your hands, wet bar soap is slippery. All those bases are slippery. They have a weird, slippery, slimy feel. Okay. Now, again, taste, touch, should never be used, okay? And I say this because I had a dum-dum last year that tried to inhale some of our lab chemicals. Again, that's the quickest way to never do anything like that again, okay? So again, there's the first two. Number one, bases have a bitter flavor, and number two, they're slippery, okay? Pause anytime you need to. Number three, bases also change colors and indicators. All right, so that's number three. Okay, so like acids, bases change colors. Most indicators turn a different color in the presence of bases than they do in acids. For example, this same bromthiamyl blue we talked about before. Now you see that's the exact same stuff we had for the acid, except when we add a base to it, notice it doesn't go to yellow or red, but this very dark blue. So when a base is added to this bromthiamyl blue, it turns from the pale blue to the dark blue. So bases turn blue. Bases, all those B words, bases, bitter, blue. Bases, bitter, blue. Okay? So it's easy to remember, in my opinion. Number four, just like acids, bases conduct electric current. They create electricity. Right? Solutions of bases conduct electricity because of the increase of these OH or hydroxide ions. Alright? This negative charge helps to create electricity. So just like acids, bases conduct electric current. That's number four. Okay. Pause when you need to. Now, for uses of bases. Alright. You've got sodium hydroxide to make soap. So if that's easier for you to remember, sodium soap, right? Sodium soap. Write it down. That's one use. Okay. Calcium hydroxide is for cement. So calcium starts with a C, cement starts with a C. So maybe that's easy to remember. Ammonia, we've talked about before, we'll see it again later. Ammonia is a household cleaner, usually in your Windex, things like that. You got magnesium and aluminum hydroxide is your antacid, like Tums. You've seen it before? Tums. So magnesium, aluminum hydroxide. You see all these words have hydroxide in them, okay? But magnesium, aluminum hydroxide, those are your Tums. All right, next. That's it. So that's it. So those are four easy ones for you to remember. Okay. Now, any questions you have, let me know. Otherwise, be sure we have this down, and we'll be able to start moving forward with some more activities from there.